Hello, can you hear me? Are you hearing me? Hello? Hello, are you hearing me? Yes. So, all right. Now my question is: last class we are doing this problem, and we create some equation. Did you get the final answer? Did you get the final answer? Tell me. Hello. Oh, why? Why no? Because we create the equations, and at the end I told you that find that and just solve the equation. Why not? Tell me. So there are the three equations. We developed three equation last class. First, this is equation number 2. Look, this is equation number 2.
There is nothing in the screen.
Sorry?
There is nothing in the screen.
Okay. You cannot see screen. Sorry. Yes. Now it will be. I think it will be available now. It's in the screen, right? All right. Tell me.
Yes, we can see now.
Yesterday, last class we finish it. The equation number 1, and this is the equation number 2, and equation number 3. And I told you solve it at your home. I think some student has done it, right? Some student has done it. Muhammad Ahmad bin Abdul Aziz Duan, he said yes. Muhammad Abdul Nasser said yes, right? Hussein Ali said no. And Hussein Ali Alawi said no, right? So these three students has done it, I think. Can you tell me the result? Hello? I have done it. Ahmadiyya, yes. Tell me result if you done. There is three equation. You see that in the screen there is three equation. This is the one equation. I make the box here. Okay. One equation, and one equation is this. Yes.
There are two ways in the slide. Which way we follow?
Which way?
There are two answers in the slide. There are two ways.
I don't know what you are saying. This is the one, right? So here, okay, I repeat it, right? So we did the summation of fx, summation of fy, and then we got the answer, right? Bx equal to 0, by equal to 0, we find it, right? Then summation of fz, one equation, summation of moment is another equation, right? Now summation of a moment x, y equal to another equation. This up, we stop up to here, right? Now I told you solve these three equations 1 to 3, and you will get the result. We have three unknown. You will get from the unknown from there, right? I told you, right? These three unknown. One is R. One is this. This is one RAZ, RBZ, and TC. These three unknown you will get from three equation. Ahmed, there can you share us the answer, please? Can you tell the answer? This is the last problem in this chapter, so I will finish this chapter. And we will start a new chapter. So I request you tell me quickly the answer, right? Tell me quickly. Solve it and tell me quickly. Already answer is there. Answer is already there in the problem. It is the solution is already there. Okay. but I want you do it and you understand what you're doing. Answer is already there. See, answer is already there. Anyone can tell me the answer? I'm just waiting for 1 or 2 minutes. Solve this equation. Another equation is here. This is another equation, right? A equal to, not A. What do you mean RA? Yes, A. In our case, I write down here RA. RAZ actually is 790. 790 Newton. Okay. Then tell me, tell me other two equation, other two result. RBZ is minus 21. RBZ is minus 21. Is that correct? Minus 2. Ali Jawad. RBZ minus 201. Okay. RBZ equal to minus 217. RBZ equal to minus 217. Okay. Let me confirm the answer. Okay. Any other? Yes. Yes. Kamal suggests to answer, and then we have still one more to know. Like TC. Please tell me the TC. TC is 707. Okay. Yes. TC is 707. You result is TC. Now, one thing we'll learn from here. TC is 707, right? Now, your answer is correct. All answer is correct. 7 Newton. So here, be careful. I tell you now something you learn it now. RAZ result become positive, right? Result is positive. We assume RAZ upward and result is upward. So that means our assumption was correct. That means our assumption was correct. Okay. Correct. Our assumption correct. RTC you see 7 plus. This is also plus. That means we say it is upward. So here also our assumption is correct. Our assumption was correct. But RBZ we assume is upward, but we got the negative result, right? It doesn't mean that your problem is wrong. It is just we assume upward. Actually, in reality, it will be downward. Let's see. Downward means 217. That's the thing. That's the difference. So what you will do? What you have to do? Just change it this one and write. This is the negative. Let's see. This is downward. So if you write down downward, then you need to omit the minus sign. Then you don't need. Then you will write down R equal RZ equal to 217. But if you keep the upward, sign, then you have to write minus 217. Okay, that's the only thing. So clear? Here is the. Are you clear? Tell me. Ashraf, Abdullah, Nasir. Are you clear? What are you? Answer me, please. Yes. So if you are clear, then you see the our then result is correct, and this is what I told you. It is written there, right? Negative sign indicate BZ is acting downward, right? Okay. So what is whatever? So here is the last example. Then we have some quiz for the for multiple choice, for just to brainstorm to know something, so you can learn by yourself. And if you have done any other question, then we want to finish this chapter, right? We want to finish this chapter. And then here is one more example. I think you do it by yourself. Here is one more exercise problem. You can do by yourself here. Exercise problem, exercise 573.
Doctor, I have a question.
Sorry?
I have a question.
Yes, please.
Our next quiz, there will be new chapters.
Next quiz, which week? Tell me.
Our next quiz, second quiz, will be in which chapters? Chapter 5 or
I'm
chapter 4?
asking you, the second quiz in which week? I forgot. It is week 10 or week 11?
I thought week 10.
If it is week 10, then I will tell you. It's chapter 5 or 6.
Okay, it will include just one chapter. Is that right? Or two chapters?
I don't know. I will tell you the Sunday maybe. Let's finish today the class Sunday, and at the end of Sunday I will inform you.
Okay, but tell us before that, Doctor, because we have another quizzes. And,
Okay, then you do the chapter 5 and 6. Okay, chapter 5 and 6.
Okay, no problem.
Okay.
Thank you.
You're welcome. So here we have the one example at the chapter. So you can do it. Answer is there. Okay. So if we have extra time at the end of the semester, maybe I will come to and explain you. Otherwise, you will learn by yourself. Right? If you don't have any other question, I want to stop this. I want to stop this chapter and start the new chapter. It's chapter 6. We'll do chapter 6, right? Chapter 6, chapter 5, we stop chapter 5, we finish chapter 5, save whatever. Now here chapter 6. Just allow that to open. Chapter 6. So what is chapter 6? Now chapter 6 is name is structural analysis. Structural analysis is the chapter 6. What is this? It is that is something written there. You don't need to read about it. We have something written there. So this is the outline. Now we will analyze trust. How to solve trust? The question is, what is trust? What is trust? Right? Do anyone know what is trust? Tell me, did you see some kind of thing, this kind of thing anywhere? In your home or somewhere? Did you see this kind of thing somewhere? Answer? This is the trust. Okay, this is the example of trust. This is trust. Did you see this kind of thing? Yes. Kamal Ashraf said in the bridge. There are many everywhere in the campus. Also, you can see in the campus. Also, you can see the warehouse. But this is the picture. Did you see somewhere like this? Yes. So this is called trust. This is called trust. Okay. This is the picture. This is called this thing. This is made of the steel. Steel. This is trust. Steel. This is the steel. This is called trust, right? So if you try, if you can see some kind of the home at village home, they make like they make wood or timber, whatever you say, timber or wood. But if it is the warehouse or something, we need to make the strong, then it is made of steel. Then it is made of steel. Okay. So this is this part is called truss, and you see, and then there is a sheet cord is there. This member is called purling. So purling. So this is, we are not about, we are not going to discuss this side. We will only discuss this part, right? This part. Okay? This is called truss. And so you said Kamal Ashok says in bridge. Bridge also, yes, in bridge also you see like this. Like in bridge it is different shape. In bridge like this. Okay? In bridge it is like this. Okay, and here is the road. Here is the road. Okay, car move on here, right? So this is bridge truss, and this is called building truss. In the building, so truss is two types: building truss. Right? So what we learn here, simple truss, and we will learn method of the joint, method of zero force member, method of section. Up to here we will learn, right? And this is we will skip this. Okay, so up to 1 to 4. So here, what is the truss? A truss is composed of slender member joined together with their end point. Now, slender member. What do you mean by slender member? What is slender member? Slender member is, look, I give the example. This is a kind of slender member. This is, sorry, I cannot draw it. Okay, I draw it by mistake. So slender member is something length is very long compared to the width and thickness is called slender member. Okay. So these are, you see, when today you try to see the in your building, not in building, or if you go to kind of warehouse or in the university, everywhere you try to see where is the truss. Okay, you find it. Try to see the member. You see this is the long, very long. Okay, and the width and thickness is very thin. This is called, this is called slender member. Something long, length is very high, by width and thickness is very small. That is called slender member. So all of them are slender member. Okay, this slender member is jointed together at the end point, right? So planar truss used to support roof and bridge. So this stuff used to use the roof. As I told you, this is called building truss. Building truss. Another and used to in the bridge is called bridge truss. I will show the picture, right? Roof load is transmitted to the truss. Now here load means in the roof. You see. In the roof load, as I told you, force, right? But when we talk about engineering terms, then we say it is actually load. Okay, then you can say that I am heavily loaded something. So this is the truss. This load of this roof is transmitted through this member, this slender member, and then here, and then here, and then goes to the support, right? Transmitted to the truss at the joint, and by means of the series of purlin. This is the purlin. Okay, the purlin. Now this is the example. So see the example, truss. This is roof truss, as I told you, and this is the bridge truss. A bridge truss could be two types. Bridge truss could be two types. Just a moment, well, sorry, I had an official phone call. Now I tell you, so truss, so building truss. Usually building truss. So here is the roof. Usually roof is like this. As you see in the previous picture. And truss, and this truss could be two types. One is the your road on the base could be the here. So, but your car can move there. And another one, as I told before, road is top and truss is at the bottom side. Truss is at the bottom side. Okay. Like this, something like this truss. Okay. So here in this type, your car will go there. So two type bridge truss and roof truss. Now truss is the members are jointed by the joint. All, as I told you, is called slender member. A slender member is jointed by the pin joint, usually pin joint or hinge. So you see, usually hinge or they are jointed by the pin joint, right? All loading applied to the, and now all the loads come to the joint and or goes up out to the joint, right? All loading are applied at the joint, and usually weight of the member is we neglect. Weight of the member usually neglect. Usually we neglect it, right? So members are joined together by means of smooth pin. As I told you, this is the pin, right? Assume connection provided center line to the joint line of concurrent. Okay. So we learned something there. That what we learned, types of the truss, and the truss is this the member are jointed by the joint or hinge joint, and all the force applied on the joint. Now you see some simple truss. This is the simplest truss. This is the simplest trust, right? Trust could be very complex, but this one is the simple trust. It's only 3 members. So 1 member, 2 member, and 3 member. Here is a 4 member. Okay, 4. 1, 2, 3, 4, 5 member, right? So simple truss form a truss must be rigid to prevent the collapse. The simplest form is that rigid is or stable. This is a triangle. This is the triangle. Usually is the angle. Okay. Now method of joint. Now, what is the method of joint? Now, what we're going to do? Like, what is our target? What is target? What we are going to do? This is the truss, okay, and we are applying always. We are applying the force. We are applying. Sorry. We apply load or force. Suppose P equal to 100 kilonewton, right? Now, you are using here the steel or wood or timber. How strong they are? They are strong enough or not? So how much load? If you put here 100 kilonewton, so how much load it will be? This member will carry AC. Suppose AC. How much load is carried by AC? How much by the BC? And how much by the AB? Right? How much load will be carried? And what is the reaction will be here and what reaction there? So this is we have to analyze. So this is we have to analyze, right? This is we have to analyze. Okay. This is the thing. This is the object. This is our objective. This is our target, right? Objective is to find the force on the member. This is the member. How much force they are carrying. Now, for analyzing, there is 2 methods. One is the joint method. Another is the section method. Okay. The joint method is easy, but long. You need long time. More work. Section method is you need more experience. But less time. It will take you less time. Usually, I will start with the joint method, and finally we'll go to the section method, and you'll find the section method is easier and more useful. But of course, to understand the section method, to use the section method, to know the section method, you need to know the joint method as well. So we learn the 2 methods, and that is written there. So joint method of joint. Here, anything is written. We don't need actually written. We'll directly start. We'll go to the start learning the method, right? What is the joint method? Another is the Alhamdulillah. Joint method. Another is somewhere the method of section, right? First, we will start now joint method. Okay, joint method. But before that, sometime I need to ask your name call. We'll try. Just wait a moment. So it is not working. So we will try later. No. Now, as I told you somewhere, where I told you, where I have drawn it, where I have drawn the class or something. Our objective is to find how much force is carrying out by this member. Force, only two types. Only two types. Only two types. It is compression or tension. There is no other way, right? Like this is the member. You can give the tension. It is tension. It is called tension. Okay, it is tension. You can pull. So pull or push. Only two types. This, right? Or this member you can push from two sides or some side, right? So it is compression. You write in C, right? But we pull or we push. That's it. Only two things, right? Two types. Only two types. So, but usually on engineering we don't say pull push. We say tension. We say tension and compression. They only two types. Now here in the any member carried load will be two types. So the member here, as example, if I tell you, member here AC member have AC, and we have AC, we have BC, and we have AB. So it will be compression or tension. We don't know. Compression, we don't know. We don't know yet. Compression or tension. Compression or tension. We don't know what is this. What is this and how much? How much load? It is compression, tension. How much? We don't know. We have to analyze. Right. Now I tell you something. Now in the drawing, how do we show compression or tension? It's very important. This is very important. Actually, everything is important in the statistics. What I am telling you, what you are learning, everything is important. If you don't know here now, you will be struggling in future courses. In third year, fourth year, you will have the more higher engineering courses, and you will be struggling there. It will be difficult in future if you don't understand now. Now, joint is suppose we show like this. The joint we show like this. Now, tension, we have two types of tension: force tension or compression. Now, if it is compression, we show like this. Arrow is toward the joint. It is compression. Okay? And tension we show like this. Arrow is outward to the joint. That means arrow is going outside of the joint. Then that means it is tension. If arrow is near to the joint, so it means it is compression. So like this, if we have two member here, so this is compression and this is tension. This is how we show it there, right? So like this, okay. So this is the way we show it. The arrow goes outside of the joint. For joint, this is for joint. Remember, for joint, right? This is you show joint. It is arrow go outside. If it is tension, so we draw like this, outward to the joint. And compression towards the joint. And for member, drawing is like this. For member, we show like this. For member, it is tension, right? And it is tension, and it is compression. All right. So this is how we do draw it, right? How we draw it, and how we show it in the analysis. Now, let's go to start our one problem. Okay, let's go one problem. We have the example here, and remember, in terms of the formula is simple. We have again only three formula. Again we use summation of horizontal equal to 0, summation of vertical equal to 0, and summation of moment equal to 0. These three things only we have. Three equations. Same three equation we learn at the beginning of the semester or something that we will be using. Nothing new. Only new thing how to analyze. Now, joint method. This is the joint. This is the example. We'll start the joint method. So if you want to know something, then we have joint. We have joint A, joint B, joint C, right? Now first we have to draw the free body diagram. Free body diagram of the joints. Free body diagram of joints. That is, we have to do it first. Okay. So joint. Now they are asking question. Determine the force in each member. What is member we have? Member we have AB. Member we have AC and we have BC. Right, 3 member of the truss, and they indicate whether the tension or compression. That's we have to do. If we use joint method, so we have to start with joint. Suppose we start free body diagram of the joint A, right? So if we joint A, so here is F, give the name F, AC, and here is F, AB. Okay, and here will be the always, that is, when we draw the free body diagram, we must have to write down the RA and RA vertical and RB horizontal, because this is the joint. Remember, this is the joint, so we will have 2 reactions, and here is the roller, and we have only 1 reaction. Remember, like this. Okay. Now, so first we draw the free body diagram in free body diagram at the beginning. Now again, listen carefully. Now we don't know, they are asking it is tension or compression. So before solving the problem, we don't know it is compression, it is tension or compression. We don't know. So what to do? We assume first. We assume all are in tension. Okay, all tension. So free body diagram, if we draw RAH, and this is the so it is RAB and it is RAH. For C, joint C, what will be like this? Joint C, again, this is the joint C, and we don't know this AC, force AC is compression or tension. We don't know. Because we don't know, you can assume anything, but we will usually start with assume this is tension. Again, force BC, we don't know it is compression or tension, that's why we assume it is tension. At the beginning we assume all tension, right? After the analysis, if we find our result is positive, so our assumption is correct. If I find the assumption result is negative, that means our assumption is wrong. We just change the direction from there to there, or there to there. We just change the direction. Now, so here and we have the RC reaction. So this is the free body diagram for the joint C. This is joint C, and this is joint B, and joint A. This is joint A and joint B. Now joint B, one member is like this. Is AB or BA, whatever you write down, doesn't matter. FAB, because we don't know it is compression or tension, so we assume it is tension. And another similarly is FBC, because we don't know it is tension or compression, so we assume this is the tension. Now remember this is BC, here tension, here tension, downward direction, right? And in joint C it is upward direction, right? So it is correct. It must have to be also opposite direction into, otherwise it will be not equilibrium. Okay, be careful about this thing. Okay, then we have the 500 Newton and there, right? 500 Newton. Okay, we have 500 Newton. So this is joint B. This is the joint B. This is joint B. Okay. Now, where to start? We start with joint A or B or C. Tell me, anyone. We have three free body diagram. I have drawn their joint A, joint B, and joint C. Free body diagram of joint C. Now you tell me where I should start. Just your idea. your imagination. Tell me please. 1 minute. A. Okay, Kamal Ashraf A. Any other answer? Morosama B. Yes. Abdullah Nasir is saying the B. Okay. Okay. Muhanna was saying it is A. Fine. Any other answer? Tell me please. Okay. So okay, it's not what. Forget about it. Now, joint A and B. Now, Muhanna or Kamal Ashraf is joint A. Why you select joint A? Tell me. Kamal Ashraf, are you hearing me? Muhanna. It has 4. Okay, and 4 forces. And so what? If it is 4 forces, then what? So what? Is good or bad? And Umar Usama and Abdullah Nasir, you tell me why B? It's more option. No, more option. Okay. I'm saying the more option. And Umar Usama and Abdullah Nasir, tell me why B? One of them is correct. Not both of them correct, but one of them correct. I will tell you which is the correct one. B. B because less option. Correct. Abdullah Nasir answer is correct. Right? Yes. Less option means less reaction means less unknown. Less unknown. Here it's more clear to start solving. Umar start solving. Yes. So different reason. Like here we have 1, 2, 3, 4 unknown. 4 unknown. Right? 4 unknown. Okay. But at B we have 3 unknown. Okay, so then we can select also C also because C also 3 unknown. 1, 2, 3. Then C. Why not C then? Okay, first we cross the A. We are not going to start with A because there is more unknown. Kamal Ashraf is saying that more option. It is actually not more option. Actually more unknown. So it's more problem. So if it is more unknown, that is it is more hard for me because I don't know. And but B and C you have 3 unknown. 1, 2, 3 here also 1, 2, 3 unknown. So why not C? Why B? Because you see, no, sorry. In C it is 3 unknown. We don't know BC, we don't know AC, and we don't know RC. But in B we only have 2 unknown. 2 unknown. So B will be the easier. One reason. Another reason is we have some numerical forces values. Here we don't know what is the value for BC, what is the AC, what we don't know. But we have some numbers here. So we can attack the problem from B. We can start from B. Now clear why we select B? Correct answer is B. Now clear? Yes. Now you tell me what is this angle? What is this angle? Tell me. How much this angle? -45°, correct? And this angle? This angle? Easy, very easy. Tell me. This angle also 45°. This, sorry, no. Altogether 90°, but this angle is 45°. Now we start with B. We start with B, right? So I draw here another. Let's start with B. Now we'll start with B and free body diagram B. So B, this is what is this force? This doctor, yes, Mohan, attend. Mohan, you have any question? To be turned off because I don't have the charge for it. Can I leave? Up to you. I don't know what you're doing there. So this is FBC and this is FAB, and here is 45-degree angle, and here we have 500 Newton with 45-degree, right? 45-degree angle. 45. This is joint B. This is joint. We are analyzing joint B. Now we have two unknowns, so we use whatever equation you want to use. First, we issue summation of F horizontal for 0. You must need to declare that which direction you are saying positive. So right side is positive. Now what force we have? Look, we have 500 newtons. So 500 is the working in the right side. So this is plus 500, right? Plus 500. Now FB is completely vertical, so FB is not in our consideration. Now we have what? FBC. So FBC, so there here and there. So FBC, this component is right side. So plus FBC cos 45-degree, because it is 45-degree, right? 45-degree equal to, there is no horizontal force, equal to 0. Now you tell me what is the result? Quickly calculate and quickly tell me. It will be minus 500 divided by cos 45-degree. What is the result? Tell me. Quickly, please. Minus 707, right? Minus 707. Now minus 707 minus. Now you see the what I told you. Now we assume the force is BC is that, right? This side. But we got the negative result. That means correct answer is, it is not correct answer. Correct will be this direction. Correct will be, I draw it. Correct will be this direction. And if it is towards the joint, that means it is compression, not tension. So you write down like this, 707, and write down compression. Okay, and you remember, you make it plus, remove the minus sign, but you must have to change the direction, otherwise your problem will be wrong. So we got one answer. Equal to 707 compression. You must have to write like this. Okay, why plus? Because we change the direction. If you don't change, if you keep like this, if you keep the direction in like this, ABC, then you have to write minus 707. If you change the direction upward, then you have to write 707. Okay, this is the reason. All right. Okay, so FBC there. Now you put the summation of, we assume summation of vertical force is 0, the plus upward, right? Upward. Now you see that you must have to change the direction and change the sign, minus, right? Now what we have now for vertical sign, in vertical we have this one, FAB, it is downwards, so minus FAB, and it is, there is no other force, it is completely vertical, right? So we don't need cos or sine. Then this force BC, so BC, now we change the direction, so now it is working two direction, right? Upward. So upward force, vertical component is FBC, sine or cos sine 45-degree, right? So FBC sine 45-degree, and 500 is completely horizontal, so it will not come, equal to 0. Now what do we know? So minus FAB FAB, and we know that it's equal to 707. So plus 707 sine 45 degree equal to 0. So now tell me, what is the FAB? Tell me please. What is the FAB? Calculate me, tell me please. Tell me please. 500, right? So plus or minus, remember it is plus, that means plus, that means our this detection assumption is correct, and that means is tension. So we write down tension. Here we don't need to change anything, right? So our time is finished almost. We have 1 minute, so we stop here today, and next class we will continue. But for today, tell me, do you have any question? Right? So here is the answer. We found the two answer, right? Next class we will continue from here. But you tell me, do you have any question? Or clear? Okay. Usually students do mistake with plus minus and the detection, compression or tension, upward or downward. Students do the mistake. That's why I am asking you. You ask me, if you have question, ask me. And today we don't have time. Next class we'll be starting from there, right? Basically, important thing is you need to understand that how we determine compression and how we determine tension. Why we change this direction and what, right? Right? So any question? If there is no question, so I now leave the session. See you in the next class or next week, right?